In this session, we're going to talk about piston design, piston rings, and the new design, the updated design and pistons that we've brought to the market for Indians. This piston here is a stock 74 80-inch piston, 74 and 80. This one here is your Bonneville piston. It's got the narrower compression rings. And this one here is the Kiwi manufactured, designed piston. This one's got two compression rings that are 16th wide, one oil ring that's 5/32. And what that allows you to do is it's actually going to translate to less drag in the motor. So you're going to get some more power out of the motor, and your cylinder walls are going to, and rings are going to last a lot longer, because this is 50% drag, less drag. It's 50% less drag or less contact area than the stock 74 and 80-inch piston. Over the years, different surface finishes on pistons have come and gone. This is a stock one that just plain aluminum ground, just plain aluminum finish. What we put on the Kiwi ones is TIN tin coating. This is actually the best for running in, scuff resistance, so you're far less likely to seize a piston like this. It's the best. TIN tin coating is the best for an air-cooled engine, splash feed motor. Even though it's old technology, even today it is the best. This is a classic case of, people say it's Teflon, but it's not. It's actually different forms of moly coating. What you can see is this one here has only got less than an hour's use on the motor, and it just comes off. Over the years we've put, you can actually see it there, it's just come off with less than an hour's worth of running on a motor. We've experimented with different coatings and modern type coatings, and none of them have held up. After a very short period of time, they come off. Another big thing we've done to aid the ring pack is Indian flatheads tend to use oil, so we're trying to reduce the oil consumption, let the rings do a better job of oil control. So you can actually see the stock one, you've got holes in the ring land itself. And what we've done with our Kiwi ones, we've actually nicked the bottom of the oil groove. So what happens is the oil comes up, and instead of jumping over the bottom oil rail and then going back to the oil drain back hole, we've allowed it to pick up on the bottom side of it. So the oil ring's going to do a better job. And to explain it here, here's your oil ring. There's two rails, bottom, top one. And so the oil would normally have to come up here off the skirt, jump over this bottom rail and back through there. So this top rail here is under a lot of its job is real critical. So we've actually lessened its job, so it can actually work a lot better by most of the oil being drained back down through here and not having to jump over that first rail. So then you've got two rails that are doing its job better. One of the other major designs that we've put into our Kiwi pistons is we have an offset wrist pin. So original pistons, the pin is centered this way, where what we've done here, rather than being centered, we're actually offset it some this way, so it's not on center. What this does is it makes for a quieter operating engine. You actually listen to a lot of Indians and you'll hear a lot of engine noise. A lot of that is coming from the pistons. One, it's the T-slot piston because it's a weak piston. This is flexing all the time. If you imagine it in and out. So this piston to cylinder wall is varying, and especially under load. You'll actually hear these motors make quite a bit more noise under load. So what we've done here is taking care of that. I've made this little crude drawing, so try and better explain what wrist pin offset does. So if everything was centered in a perfect wheel, you've got combustion and everything's going down through the center, it would be okay. The piston is not, basically, the piston is not rocking. It would be just going straight up and down. But what happens is you've got the combustion or power stroke. So when you've got firing, combustion, the explosion, then you've got the power stroke, so the connecting rod's on its angle. So what it's wanting to do is flex this piston skirt this way. So imagine it, you've got the boom explosion on top, and it's wanting to flex the piston this way because of the angle of the rod. So, and just all the forces that's going on. So by offsetting the wrist pin, you can see this is rather crude, but hopefully it'll work. But by offsetting it some, this is exaggerated. This amount is really critical. I played around with this for several years before I got this right. But we put the right amount in offset into it, just kicked it over this way to the thrust face, because you got two thrust face, you got the minor and you got the major. So this would be the front of the bike. That's why you've always, in the old pistons, you got the T-slot going to the front. So what's happening is the piston is always wanting to kick this way under load. It's wanting to kick this way. So that's why they call this the major thrust face and minor thrust face. Piston skirts are tapered and oval. So at the top of the skirt, it's smaller in diameter than the bottom, and the piston skirt itself is also oval. The reason for this is because there's a lot of heat being generated from combustion, and so once it gets operating, it actually goes more into a round form. So what I've done here is I've made this other little crude drawing. So you've got combustion up here, a lot of heat generated, so it's going to swell, and a lot of heat is transferred down through the piston into the wrist pin bosses and down through the connecting rod. So that's why you've always got more clearance up here, because you've got more expansion going on. Now the piston itself is oval. It's not round, even though to your naked eye it is round. Once again, you've got the wrist pin axis through here, which would actually be like this. So piston through here is actually a smaller diameter than this way. So this way is smaller in diameter through here, because once again you've got all the heat being generated from here coming down through these pin bosses and then the pins, so there's a lot more heat, and you can actually see there's a lot more mass here, so it's going to generate more heat, or it's going to have more heat, so there's going to be more expansion in this area, so it's going to grow out this way. We've cleaned up the underside of the pistons as well. Now, this is quite a busy piston design where you've got a lot of gussets going across, a lot of sharp edges, and things just don't want to flow. So what we've done over here to the Kiwi piston is we know what head thickness we need. So we've cleaned up all that, so we've got a nice flowy, so the heat transfer through a piston is about as even as you could possibly get it. So it just cleans it all up. The wrist pin, we've narrowed down the wrist pin a little bit. That's why we've got these cutouts through here. And this actually reduces the chance of piston sticking and seizing. We've got oil is at the right, little oil grooves at the right pressure points here, so they're lubricating the piston at the right angles. And the overall weight of the piston is the same as the stock one. So we haven't interfered with anything in that department. So these pistons are a heck of a lot better upgrade than the stock one. Gentle on the cylinder walls, can get a little bit more power out of it. Better oil control. They're going to run quieter. because they've got the offset wrist pin, which means you're going to have an arrow on the top. Arrow goes forwards. Arrow points to the front wheel of the motorcycle, front of the motorcycle. And you've got TIN tin coating, so you've got good scuff resistance during braking. All around a far superior piston than what Indian ever put out and what else is on the market as well.